Good morning, students. Today I would like to explain you about the topic connected and biconnected components. This topic is related to Unit 3rd, first part, and this is the last topic in the first part of Unit 3. So before going to discuss about connected and biconnected components, I would like to explain you about what is connected graph and what is connected component. Next, what is biconnected graph and what is biconnected component. In the syllabus, you are having only biconnected components. Before going to discuss about biconnected components, first you have to learn about what is a connected graph and connected component. So coming to the connected graph, a graph is said to be connected if and only if there is a path between every pair of vertices. For example, see this graph here. Here total 5 vertices are there. There is a path between each and every pair of the vertices. For example, consider A and E as a one pair of vertices. There is a path between A to C and C to E. If you take any pair of the vertices from the graph, there must be a path compulsory. Then such graph is known as a connected graph, and this connected graph consists of only one connected component. Coming to the next example, so this is also a connected graph. This graph is also having one connected component. Coming to the third example, so this is a graph which consists of two connected components. This graph is known as a super graph. Here, this graph consists of two connected components. Therefore, we can define connected component as connected component of graph G is a subgraph in which any two vertices are connected to each other by the paths and which is connected to no additional vertices in the supergraph. For example, see third example. So this is a supergraph. This graph consists of two connected components. So this is connected component 1 and this is connected component 2. So this is a subgraph and this is also subgraph, but these two subgraphs are not connected with each other. That is about the connected component. Hope you have all understood what is connected graph and connected component. Once again I am repeating, connected graph is said to be, a graph is said to be connected if and only if there exists a path between every pair of vertices in the graph. And the connected component is subgraph in which every two vertices are connected to each other by paths and which is connected to no additional vertices in a supergraph. Hope you have all understood about what is a connected graph and connected components. And the next, I would like to explain about biconnected graph and biconnected components. So a graph is said to be biconnected if and only if it doesn't have any articulation point. So then what is articulation point? For example, see this graph here. In this graph, vertex 3 is articulation point because on the removal of this vertex 3, this graph is divided into two components. Okay, and each component is referred as a biconnected component. So, what is articulation point? Articulation point, a vertex in a connected graph whose removal will disconnect graph into multiple components. Here, by removal of vertex 3, this graph is disconnected into two components and each component is referred as a biconnected component. And see some more examples related to biconnected component. So see here, this is one graph. This graph consists of three vertices. On the removal of vertex B, this graph is disconnected into two components. One component is A and other component is C. So how the components will be decided means, if any vertex removed from the graph, then there should not be any path from one component to the another component. For example, see this graph. On the removal of vertex B, there are two components A and C, and there should not be any path between these two independent components. Clear? See the second example. So this is a graph consisting of 4 vertices A, B, C and D. So this is not a this is a biconnected graph because this graph has no articulation points. Because if you remove a vertex B, there are two components A and C, but these two components are connected with the vertex D. So this graph is a biconnected graph because it is not having any articulation point. Next is the third example. So this is not a biconnected graph because this graph consists of articulation points. For example, on the removal of vertex C, this graph is divided into disconnected into two components. One component as AB and other component as D, E and F. So this is not a biconnected graph. See the example 4. So this is also not a biconnected graph because on the removal of vertex D, this graph is divided into two components. So this part has one component and this part has another component. Again, on the removal of vertex D, this subpart is again divided into two components. One component as three components. One component as AB and other component as E and other component as F. Therefore, in this graph, there are two articulation points. First one is C and second one is D. Total number of components, total number of biconnected components of this graph are 4. First component is G, F and H. This is AB second component, E third component and F is a fourth component. Hope you all have understood about what is a connected component and biconnected components. Once again I am repeating, a graph is said to be connected if and only if there is a path between every pair of the vertices. Connected component is a subgraph in which any two vertices are connected to each other, and also there should not be connection between any two vertices which are in the supergraph. And what is a biconnected graph? A graph is said to be biconnected if and only if it doesn't consist of any articulation point. Then what is articulation point? On the removal of any vertex in the graph, then the graph should be disconnected into multiple components and that particular vertex is referred as a articulation point and each component is referred as a biconnected component. Thank you.